Okay, welcome to the third questions in electric potential and potential energy. Okay, let us start. 2-point charges Q1 and Q2. Okay, Q1 is a positive point charge. Okay, better I write down the information here, easy for me to retrieve. This is this is a positive 2 microcoulomb. And then for the Q2 is a negative point charge, negative 6 microcoulomb. Okay, good. So place 4 cm and 5 cm from the same point P. Yeah, and this is the distance. We have 4, we have 5. Okay, now calculate the electric potential at point P. Electric potential at point P. So the questions are asked for potential at P. Yeah, due to the charge. So potential at P, you want to find potential at P. So that means you want to find total potential at P, because we have 2-point charges. So we want to find the total potential at P. The Q1 provide potential for P. Q2 also provide potential for P. So potential at P, you must total up V1 and V2. Total up V1 and V2. Again, potential is a scalar quantity. You just add up the potential. No need to do the vectors. No need to do vectors. No need to draw any arrow or directions or XY component. No. Yeah. No resolve XY. No vector diagram. You just add up V1 and V2. You just add up like 2 plus 1, 3. 3 plus 2 equal to 5. 5 plus 6 equal to 11. Yeah, you just total up like a scalar quantity, like a number. You just total up like that. Okay, just total up V1 plus V2. Okay, so we have 2-point charge, isn't it? We have 2-point charge, so you must have 2 potential. 2-point charge, 2 potential. Q1 you have V1, Q2 we have V2. So we have KQ1 over R1 plus KQ2 over R2. Again, scalar quantity like potential. If the charge like Q2 is a negative charge, okay, negative charge, the charge, you must have the negative sign. You must substitute in the negative sign, because the negative sign in potential is about the number scale. You know the number scale I mentioned in the lecture video? The negative sign in the scalar quantity like potential is about magnitude. It's about magnitude. The more negative, the lower the potential. Yeah, the more negative, the lower the more negative, the lower the potential. Okay, that's it now. So now let's do it. Let's find the potential at P. So K is I can factorize out this K, isn't it? K is a common, right? K is a common, as you can see over here. K and K over here is common. Why not we factor out to make our calculation cleaner? Yeah, cleaner. So 9 exponent 9. Then you have Q1. Q1 is a positive 2 microcoulomb. So why I put red? Why I put red color for these calculations? So let us change. Change this to never mind. Just write all over again. I'm sorry. So K is 9 exponent 9, right? 9 exponent 9. Factor the K out, and then Q1 is 2 microcoulomb. Okay, so let's substitute 2 micro. Micro is negative 6. Micro is negative 6. And then R1, what is R1? R1 is this one. Q1 from P this is R1, and this is R2. Okay. So this is R1. So which is here 0.04, isn't it? Yeah lah. 4 cm divided by 100, you get 0.04 meter. Meter. Okay. Next, plus. Okay. Q2 is a negative point charge. As I said, scalar quantity, the charge, you must have the negative sign. You must have the negative sign. The negative is so important for scalar. It's about the magnitude. So the charge, if the charge is a negative charge, you must put in the negative sign. Okay, let's put in the negative sign. Yeah, So we have the negative here. You see the negative here. So it's a Q2 is a negative 6 micro. So negative 6 micro. Okay, negative 6 micro. So 6 exponent negative 6. Which is how far is it? How far is it? Q2 is 5 cm from P. 5 cm from P, which is 0.05. 0.05 meter. Okay, 0.05 meter. So, what's the value? Let's calculate, and I got the answer. Negative. You have negative. You see the negative sign. Don't just the negative sign. Don't omit. The negative sign here you must maintain. It's very important. The negative means very low potential. It's about the magnitude. Okay. Yeah. So the negative here, the negative sign here is a must. Means this potential at this point is very low. Very low potential, very negative. It's not direction to the left or downward. It's just this negative here just means it's very negative potential here. Very negative potential means very low potential. Yeah, maybe I can just write there. Very, very low potential. Yeah, very low potential. Very low potential. Very negative, very low potential. The negative sign here, it means very low potential. Okay. So now, now let's continue. What is B? If a charge Q3 from of 3 microcoulomb moves from, you see, moves. The word moves means what? The word moves here, it means the Q3 is the test charge, because the test charge always likes to move around. You understand that? This Q3 moves around, yeah, shows the characteristic of a test charge. So Q3 is a test charge, likes to move around. It's moved from where? From infinity to point P. From infinity to point P. So find the change in electric potential energy for this charge. The change in electric potential energy. So the question asks for change. The change. The word change is delta triangle. You understand? Potential energy. So this means what? This means the change means delta, isn't it? Delta. This means change. Change means delta. Potential energy means U. Delta U. Delta U. Okay. From where? Okay. Change in potential energy for this charge. So, what is actually delta U? You still remember what is delta U? Delta U, the change in electric potential energy, is actually the change in electric potential energy. Actually, is the work done. Is the work done? Okay. Is the work done. Work done is the change in electric potential energy. So this one, it moves from where to where? From infinity to point P. From infinity to point P. So it's actually the work done to bring the test charge Q3. Work done to bring the test charge Q3 from infinity. From infinity is the initial. Infinity is the initial, and P is the final. Okay. Final. So work done to bring the charge from infinity to point P. So final is P. So if you want to find the change in potential energy for this charge, we always take final minus initial. If you want to find the change of something, yeah. So remember, if you want to find the change of something, we always take the final of something minus the initial. Want to find the change, the increase of something or decrease of something, we always take final minus the initial. So our final now is what? Our final is P. Our initial is infinity. So it is U infinity. No. U P minus the U infinity. Okay. U P minus U infinity. So that's how you get this one. You see, is delta U P infinity, which is this one. So the question actually wants delta U P infinity, final minus initial. Final minus initial. Okay. So work down from infinity. It work down from infinity to point P. It is delta U P infinity. That means the final potential energy minus the initial potential energy. Okay. Delta U P infinity is also equal to Q naught delta V P infinity. Yeah, P infinity. So delta P V P infinity is VP minus V infinity. Yeah, it's like final minus initial. Okay, I hope you already understand about this. Now, just now we already got potential at P, isn't it? We already got the potential at P. Potential at P is this. Potential at P is this one. So this is the potential at P. So potential at infinity we don't have yet. Potential at infinity we don't have. So what is the potential at? Because this is the potential at P. So he want to find the test charge. Test charge like this one, Q3. This is Q3. This Q3 is brought from infinity to point P, isn't it? From infinity to point P. P infinity is the initial, P is the final. Yeah. So we already got the potential at, we already got the potential at point P. We don't have the potential at infinity yet. Potential at infinity. So how to find? Potential at P, we already got V1 plus V2. We did calculate out, but potential at infinity is also you do the same thing again. Potential at infinity is V1 plus V2. V1 plus V2, which is V1 plus V2. So the distance is infinity. Because how far is infinity from Q2 and Q1? It is infinity distance, isn't it? Infinity distance, infinity distance. So that's why the distance is infinity, infinity. So R is infinity. So when anything divided by infinity, you get 0, right? You get 0. And then Q naught, the test charge is actually, the Q naught here is Q3. Okay, so now we got everything we need. So let's do it. Yeah, let's do it. What is our Q naught? Our Q naught is positive 3 microcoulomb. Okay, positive 3 microcoulomb. So 3 micro, negative 6. Okay, and then VP is negative, this one. Yeah, just put in negative 6.3 exponent 5. Okay, and then minus our voltage at infinity, which is 0. So we get what? We get the answer negative 1.89 joule. So what does it mean by the negative sign here? Is it means that direction to the left? No. The negative sign here just means that when the test charge move from infinity to the point P, it has lost in electric potential energy. The potential energy of Q3 actually decreases as it move from infinity to that point P. Yeah, it loses electric potential energy because it's just like this test charge is being pulled by this negative point charge. This point is being pulled, so it has lost in electric potential energy. Okay, that means you can either say this is a work done by electric force, or you can also say that it encounter loss in electric potential energy as it moved from infinity to that point P. Yeah, loss. Yeah, it lost this amount of 1.89 joule of energy. And the negative means. Yeah. So now, at last, want to find when the charge Q3 at point P, calculate the electric potential energy for the whole system of charge. The word system. The word system, it means the potential energy for all charge together, not just energy for certain charge, but for all and for all charges towards each other. Okay, now Q3 is over here. Q3 is over here. Now I want to find the potential energy for the whole system. Whole system means for the total potential energy for all. Means this one. The total potential energy. If you look, you saw the word system. The word system, that means you need to take relationship between each pair. Between 1 and 2, 1 and 3, 2 and 3. The word system. Or you can say system, or you can say all charges. The total electric potential energy. The total electric potential energy for either is system or total electric potential energy, or for all charges, not just one charge, but potential energy for all charge, the system of all charges. Then this is the equation to do it. Yeah, you need to find the potential energy. You need to find the relationship between each pair, 1 and 2, 1 and 3, 2 and 3. Yeah, U total is 1, 2, 1, 3, and 2, 3. Okay, so let's substitute. Potential energy is K Q Q over R. So K is common for all. Just factor out the K. Again, our negative charge here is Q2. Q2 has a negative charge. So remember, scalar quantity, the negative sign is very important. It's about the magnitude. So for the charge Q2, you must have the negative sign. For other, just a positive sign. Yeah. Okay. So for Q3, what is the Q3 is a positive 3. Okay, put as a positive 3 microcoulomb. Q3, that's positive 3 microcoulomb. So for Q1 and Q3, put positive value, but Q2 you must put in the negative sign. Okay. Okay. Now let's do the questions. So K is a 9 exponent 9. This will be long. Q1 is easy. Put in the information here, easy. Yeah. 2 microcoulomb. So 2 microcoulomb, 2 exponent negative 6. And then Q2 is a negative. So you must have the negative sign. Negative 6. Negative. The negative sign very important. Negative 6 micro. Over the distance 2 and between 1 and 2 is 3 cm, isn't it? Between 1 and 2 is 3 cm because it's a right angle triangle. So 3 cm 0.03 meter. Okay, plus Q1 and Q3. Q1 and Q3, 2 and 3 microcoulomb. Okay. Yeah. So 2 and 3 microcoulomb. 2 and 3 microcoulomb. Good. So how about Q1 and Q3? 4 cm. 4 cm is between them. 4 cm, which is 0.04 meter. Okay. And then plus Q2. Q2 is a negative charge. So negative sign. Negative 6 and 3. Negative 6 and 3. So Q2 is negative 6. Negative sign you must put. Negative 6 micro. Negative 6 and 3 micro. Okay. So what's the distance between them? Distance between them is 5 cm. 5 cm. 5 cm. 0.05. Okay, so I got everything. Now I just calculate. Yeah, I just calculate and see what's the answer. I got the answer is negative 5.49 joule. Okay. So the negative sign here again is about the magnitude. It's about the magnitude itself. So it's not about direction. Okay. So the potential energy for this system is negative 5.49 joule. That's all for these questions, and thank you for watching. Let's move on to the next one. Yeah.